Good morning, students. This is regarding the problem of the time period of a pendulum and on what factors does the time period of a pendulum depend on. Okay, we'll try to find that out. We'll try to establish a relationship between the time period of a simple pendulum and the factors that the time period depends on using the methods of dimensions. Okay, so we know that the time period T of a pendulum depends on three factors. One is the mass of the bob. Another one is the length of the pendulum, and the third factor it depends on is the acceleration due to gravity. Okay, so that means we can say that T is proportional to the mass of the bob. Okay, we can write it as m to the power a. T is proportional to the length of the bob. We can write it as L to the power b, and T is also proportional to the acceleration due to gravity g to the power c, where a, b and c are the dimensions of the physical quantity: mass, length and acceleration due to gravity. Okay, so we can put them together like this. We can write T is proportional to m to the power a, L to the power b and g to the power c. So this is the initial relationship that we have established from the fact that the time period depends on mass, time period depends on length and time period depends on the acceleration due to gravity. They can be written like that. So first job is to establish a primary relationship. Now in order to get rid of this proportional sign, what I do, I write T is equal to K, which is a constant, then m to the power a, b to the power, L to the power b and g to the power c. So this is the relationship that we have established. Obviously this is not the answer because we need to know the value of A, B and C. Okay. So let's do that. We will do this using the methods of dimensions that we have already learned. Now what is the dimension on the left hand side? Left hand side you have got T, which is the time period. So I will write left hand side, which is the time period. Its dimension is only T. That is the dimension. T stands for time period, it's actually time. And then right hand side, what will be the dimension? Right hand side I have got first term is K. K is a constant. You don't actually require to count this because K is a constant. So that is not considered. We do not consider constants here. We will start from M onwards. M. So we will have to write M to the power A, then L is the length, so L to the power b, and then g means acceleration due to gravity, so it is actually L t to the power minus 2 to the power c. Now if we simplify, this becomes m to the power a, L to the power b plus c and t to the power minus 2c. So that is the dimension on the right hand side. Now according to the principle of homogeneity, you know that the dimensions on the left hand side should be equal to dimensions on the right hand side. So if you equate left hand side with right hand side, then what do you get? This is left hand side is T. This can also be written as m to the power 0, L to the power 0 and t to the power 1. Okay. So we can say that m to the power 0, L to the power 0, t to the power 1 is equal to m to the power a, L to the power b plus c and t to the power minus 2c. Okay. Now what we will do? This is actually an identity. So we have to equate the powers. Okay. To find the value of a, b and c, we need to equate the powers. So I'll do that over here. So when you equate the powers, what you get? You get A is equal to 0. So you get A is equal to 0 and B plus C is equal to also 0 and minus 2C is equal to 1. So minus 2C is equal to 1. That means this implies that C is equal to minus half. So if C is equal to minus half, then from this equation you get B minus half is equal to 0. Therefore B is equal to half. So you know all the values of A, B and C. If you put this back into the original equation, then what do you get? You get, I am writing it here, the equation becomes T equal to, it becomes K, then m to the power 0, okay, then your L to the power half, and you get G to the power minus half. This is what you get after putting back the values of A, B and C. Now if you further simplify, then what you get? You get this as just K, then root over L upon G, because root over means to the power, and M to the power 0 becomes 1. Now experimentally we found out that K is equal to 2 pi. So if K is equal to 2 pi, then your T becomes equal to 2 pi root over L upon G. So this is the final equation that establishes the variables length and acceleration due to gravity with the time period.